So, shall I wait for a few minutes? Okay,
Okay, ma'am.
let's wait for 5 minutes, and after that, I will start our today's discussion. Okay.
Can I ask some doubts, ma'am?
Yes, yes. So,
Yeah,
since
ma'am.
okay, just wait for 5 minutes, and then we will start our session because uh, other people, the doubt you have, other people may also have the
General.
same doubt.
Okay, okay.
Okay,
Okay,
so
ma'am. Okay.
yes, anyone want to tell anything? Pothi, Supriya, do you want to tell something?
Can I say something, ma'am? Like, it's like
Yeah,
a
yeah, yeah.
general doubt, you know.
Okay.
Yeah, this is I'm Krishnaveni from Vijayawada, Andhra Pradesh, working as a lecturer in the Department of Mathematics, National College. Luckily, we have on Saturdays only half day, so I'm able to attend the session now live. So is it mandatory that we need to attend like this live sessions? Otherwise, lectures recorded though like this can be shared with us in the next day so that we can watch afterwards also, if not possible.
So this
Thank
is
you.
the okay. What I okay, I want to clarify that this is the live session. I mean, if you have any doubt, you can ask me. I will try to clear.
Yeah,
Uh, Supriya, do you want to tell something?
my name is Supriya. I'm studying in degree final year. So NPTEL is mandatory, so that's why I is logging in NPTEL.
Okay. Uh, I mean, can you? What is your doubt? I mean, I didn't get it.
No, no doubts.
Okay, you are
First
just
week of
introducing. Okay, okay, okay. So let's start today's discussion now. Uh, Good afternoon, everyone. I
good
am
afternoon.
uh, Supriya. If you have finished, then you can just mute for now. And if anyone have any query, then first raise your hand first, and then tell me one by one. Okay. So when you are trying to tell me something, just first raise your hand. So
Okay, ma'am.
good afternoon, everyone. Myself Moma Samanta from IIT Kharagpur, and I am your NPTEL PMRF teaching assistant for this July session for the course July 2020, starting from July 2026. and the course name is A Basic Course in Number Theory, and which is taken by, the course instructor is Professor Sripad Garg from IIT Bombay. And this tutorial session is actual live tutorial session. So what we will do here is that I will try to explain from something from my side, and the most important thing is, if you have any doubt, any query, then just let me know, and then I will try to try to answer to all of you. Okay, so first let me know, so have you seen all the lectures from week 1? Okay, so today let me write first. So today is 25. Okay, so outlines of today's course are: so first I will try to give some preliminaries. Then we will discuss the topics which has covered by professor. That means divisibility, and next is okay. So these are the outlines of today's discussion. Along with that, some questions. Okay, so first I would like to ask you, one by one, tell me if anyone has any doubt from the lectures. Please first please raise your hand, then okay. So anyone has any doubt from the lectures? So I will wait for 2 minutes. If you have any doubt, just let me know, otherwise I will start uh, from my point of view. Okay, I will start solving some questions and giving some preliminaries. So it seems okay.
Hello, ma'am.
Yes, tell me.
Ma'am, I have a doubt in question number 6 in week 1 assignment.
So actually, I can give you some hints, but I cannot solve it thoroughly because assignment questions are.
Okay.
So, can you tell me what is your doubt? Question number 6. Then I can write and.
Ma'am, in question number 6, I am not able to uh, know how to approach this type of question. So, this is my doubt.
So, just can you tell me the question? Then I can write it down, and because right now I don't have that.
Question is the number of primes p such that 20 divides p minus 3 and 3p minus 1 less than is equals to 2024.
So,
Here we want to know the number of primes p.
yeah. So, what my suggestion is, you know the prime numbers, right? You know the definition of prime.
Yes, ma'am, yes.
So, what is that?
And if there are only two devices, one and the number itself.
Okay, then we call this number prime. Then you can list all the numbers which are uh, okay. So then you know you have the list of primes. That is what you have to know before. You have list of primes is known, and so what you have to note is that first p minus 3, this is divisible by 20, right? So p minus 3 should be p minus 3 should be multiple of 20. Then you know those kind of integers uh, which are multiple of 20. Okay, I 1 minute. Krishna Veni, so live sessions are not mandatory, but I obviously I will share the recorded video so that you can watch, and I think NPTEL team will share you that recorded video. Okay, this is not mandatory.
Thank you. Thanks.
So now see that p minus 3 is divisible by 20. This is one condition we need, and another condition is 3p minus 1, this is less than 2024. So since you know the all the prime numbers starting from 2, then you can see that which primes are satisfying this condition, first condition, and also the second condition. So you have to verify that. Okay.
Okay, ma'am. You mean we have to list it manually?
Yeah.
Okay, okay. Okay, ma'am. Thank you.
So if 20 has to divide any number, it must be such that it contains 0. So yes, that is the condition. I mean, from you have to list all the primes such that these two condition holds, 1 and 2. Then obviously which kind of integers are divisible by 20 you know, and which integers are less than equals to 2024, that also you know, and from there, from these two conditions, uh, you have to find all those primes manually. Yes. So is it clear, Kamaljit?
Yes, ma'am. Yes.
Okay.
Okay.
Anyone else? Okay, so let's start Hmm, I am starting from my side. I mean, what I want to tell you in for this lecture. So, number theory, this is a branch of mathematics which studies uh, mainly with the integers. Okay, and this branch has several. This number theory has application to several other branches of mathematics as well. And I admitted, right? Yeah. So we before diving into the basic some theories of number theory, let's recall some notations and preliminaries that will be useful and throughout these lectures. So you all, do you know the definition of set? I hope you all know. uh, Still, so you all know the definition of set. This is just I am writing, well defined collection of objects. This is the definition of set. So under set, uh, we can consider finite set and another is infinite set. So finite set which contains finitely many elements, and infinite set which contains infinitely many elements or objects. Okay, so uh, see some example. We all know the set of real numbers, right? This is set of real numbers, and set of real numbers is the union of these two sets. This is set of rational numbers, yes, objects must be distinct, like yes. So the basic definition of set, that what you have uh, studied in your class 11 12, I think. So well defined collection of distinct objects. So set of real numbers, this is union of set of rational numbers and set of irrational numbers. And then you also know the this notation, set of integers, and also set of which looks like this. This, and this side from here to all these infinite collection, these are called negative integers, and from here to all these sets, infinite set, this is called, these are called positive integers. Okay, so we denote the set of positive integers by natural numbers. that is okay. This set is exactly consisting of 1, 2, 3, infinitely many. Okay, so there is a and set of rational numbers. How it is defined? This is like a by b, such that a, b, this belongs to z, and b is not equals to 0. This is the definition of set of rational numbers. I mean, rational number set is defined in this way, and the elements which are not in this set Q are called irrational numbers that belongs to Q complement. Okay, so here we see that this kind of chain we have n, this is subset of Z, this is subset of Q, this is subset of R, right? So here mainly in number theory we study about these two sets, this one and this one, set of positive integers precisely, and sometimes we also use set of the whole integer set. Okay, so if I want to draw, this is 0, this is the real line, and 1, 2, 3, 4 like this, and here -1, -2, and this side is totally, these integers are natural numbers and these are negative integers. Okay, and 0 is neither negative nor positive, that is 0. So now note that all these sets, set of natural numbers, set of integers, set of rational numbers, real numbers, all have two binary operations, right? All these sets have addition denoted by plus and multiplication denoted by dot, and also these are totally ordered set. What do we mean by totally ordered set? This totally ordered set means that for any two element A and B from this set, uh, from some given set, I mean which has which set we are talking about, either A less than B or A greater than B or A equals to B. Any one of these three conditions will always hold for any two pair AB from that set. Then we will call that kind of set as totally ordered set. And see here, all these sets A and Z, Q and R, all are totally ordered set. Okay, so we have seen in the lecture that set of natural number and set of integers, these are totally ordered set. What is the order? Say for let's talk about the n first of this set n. Let AB belongs to n. How the order is defined here? When we will say A greater than B, when to say? We say A greater than B if A minus B belongs to n. This was the order relation we have defined, we have seen in the lectures, and so yes, totally ordered set means trichotomy law, and these are same. the meaning are same, trichotomy or totally ordered set. So you are right, we have messaged me. Yeah, Kamaljit, you are right. So now we will start with some, I mean the set of natural I mean the theory of the number theory. It has a fundamental principle, we call it Euler ordering principle. Okay. This number theory, this is a fundamental principle of number theory. What does it say? Euler ordering principle says that for every non-empty, this non-empty term is very important, every non-empty subset of natural numbers contains a least element. Least element in which sense? That is, there exists some A belongs to S, the subset, okay, every non-empty subset S of n contains a least element. That is, there exists some A belongs to S such that for A is less equals to B for all B belongs to S. Okay, what does it say? So every non-empty subset of the set of natural numbers will always contain a least element. That is, take any element from this set S, we can always get a element, unique element A in S such that A is less equals to B. This is a fundamental principle of number theory, and this is used to prove many theorems in number theory. So another important property of number theory is principle of mathematical induction. Okay, so it is used to prove various statements in number theory. I hope you have seen some proof in the lectures which I mean sir have used this principle of mathematical induction to prove some theorem in the lectures. Okay, so here I am stating it again. What is the principle of mathematical induction is let S be a set of is my handwriting clear? I mean, do you understand my handwriting? Okay, okay. So let S be a set of positive integers with with the following properties. Say what is the properties? First is 1 that is belonging to S, and second condition is for some k belongs to n, 1 to up to is 1 up to k, this belongs to S. If okay, there should I should write if this belongs to k S, then k plus 1 also belongs to S. These are two conditions which this set S is satisfying. Then what we can conclude? Then S equals to the set of all natural positive integers, that is S equals to n. Okay, so what is this principle of mathematical induction saying? It is saying that consider S to be a subset of natural numbers which is satisfying two properties. First is 1, this element is always in S, and second condition is for some natural number k, if 1 up to k these elements belongs to S, then k plus 1 this will also belongs to S. These are two properties S are satisfying. Then we can say that S is the set of all positive integers, that is S equals to n. So this principle of mathematical induction, this is very useful to prove certain statements. I mean, it is not useful to guess how some property we are getting, but if we guess somehow that some statement involving natural numbers are is true, if we can guess, then to prove this statement we can use principle of mathematical induction. So actually I right now I cannot remember what is Peano's axiom. Maybe they are same or it might not be, but I actually right now I cannot tell anything. But this is actually second principle of mathematical induction. There is I mean in some books you can find there are two principles of mathematical induction. First principle of mathematical induction is saying S has to satisfy two conditions. First is 1 belongs to S, and second is if k belongs to S, then k plus 1 belongs to S. In that second, for this second condition, they are not considering that 1 up to k that has to be in S. They are only saying that if k belongs to S, then k plus 1 belongs to S. S is satisfying this property. Then we can say S equals to n. But to prove some statements, we need to actually both are same, but it will be very complicated to show that if k belongs to S, then k plus 1 belongs to S, and it will be easier to see that if 1 up to k that belongs to S, then k plus 1 belongs to S. So I will explain it with an example. So Ganga, you are saying that okay, no, Hars, you are saying that this is Peano's axiom. Actually I right now I cannot remember what Peano's axiom is, so I will see and let you know in our next tutorial session. And okay, maybe you are right. So yeah, maybe. And Ganga, you are saying, is this itself induction hypothesis? So what do you mean? Induction hypothesis means inductively, if we want to show prove some statement inductively, then we use principle of mathematical induction. Okay, so this first condition, uh, if S satisfies this first condition, we say this is the base case and this is the induction step, this second condition. Okay, so let's see this with an example. So we are now we are going to use this principle of mathematical induction to prove some statement. So let's I think I can clear Ganga's question by stating this example. Okay, so that a plus b whole power n, this is equals to summation k equals to 0 to n, n choose k, a power n minus k into b power k. So what is this equation? This is called binomial expansion of a plus b, right? Where n is some this is for all n belongs to n. So this is what, yeah, binomial expansion. This is what we want to show by using principle of mathematical induction. Okay, let's start the proof. So what is induction hypothesis saying? Principle of mathematical induction is saying if 1 belongs to S and k plus and 1 up to k belongs to S will imply k plus 1 belongs to S, then we can say that S equals to n. So consider that Pn, this is the statement a plus b power n equals to summation k equals to 0 to n, n choose k, a power n minus k, b power k. Okay, so this is the hypothesis. This is called induction hypothesis. Okay, so for n equals to 1, that is base case. So if 1 belongs to S, I mean if base case is satisfying, we have to check whether base case is satisfying or not. For n equals to 1, what we have? A plus b whole power 1, this is left hand side, and what is the right hand side? How we can write it? This is LHS, and we can write it as 1 choose 0 into a power 1 minus 0 into b power 0 plus 1 choose 1 a power 1 minus 1 into b power 1. Pn is the statement we want to show. So we have to show that a plus b whole power n equals to this summation, right? So we are assuming that we are trying to show that this statement is true for all n. Okay, so this is the hypothesis, means the statement, given statement which we are trying to show. So for we are trying to show it by using principle of mathematical induction. So we have to check whether 1 is satisfying this Pn or not. We are finding that this is the expression we want, that is this is the expression in right hand side, RHS. So therefore what we can say, P1 is true. Now induction step. What was the second statement? Second statement was, if 1 up to k these elements belongs to S, that is if in our question what we should write, assume that Pn is true. Pn means that hypothesis or statement is true for n equals to 1 to up to k for some k belongs to n. What we have to show, that P so everyone I mean, I don't know why this is showing me that call ends in 15 minutes. So if this call ends, then can you please rejoin this same meeting link? Please raise your hand. Okay, this same meeting link will work. Okay. Okay. So we still we have 15 minutes. So let 1 up to k, these are for these integers Pn is true. Want to show Pk plus 1 is true. So since Pk is true, what was Pk? Pk was saying that a plus b whole power k, that is this has expression k equals to 0 up to n sorry here say m, because we already have used k. Pm plus 1. Okay, so k equals to 0 to m, m choose k a power m minus k into b power k. We have this one. Now want to show that Pm plus 1 is true. What is we have? A plus b whole power m plus 1. What is this? This is our LHS. This is equals to a plus b whole power m into a plus b. So if you expand it, then we have k equals to 0 to m, m choose k a power m minus k b power k into a plus b. Again do further calculation. This expression we can write it as m choose 0 a power m b power 0, that is only a power m, plus m choose 1 a power m minus 1 into b up to m choose m minus 1 a power a into b power m minus 1 plus m choose m b power m into a plus b. Do further calculation, you will find that this is a power m plus 1 plus summation k equals to, what should I write? You can for this step, if you don't understand, you do the calculation by yourself, and you will find that ultimately we can get this one, k equals to 1 up to n. We will have these two combination, m choose k minus 1 plus m choose k. This times a power m plus 1 minus k into b power k, and another term which is left is b power, and that means m choose m b power, that is exactly, I mean m choose m means 1, that is exactly b power m, right? So what we had, so this term if you can calculate, then what you will find, okay, so this is a power m plus 1 plus summation k equals to 1 up to m. That term was this one, m choose k plus 1 plus m choose k. What is that? Do you know? You can calculate it using the definition or expression of m choose k minus 1 and m choose k. Do you know what this sum will give you? Anyone? So if you calculate it, you will get, okay, I will show you how to get it. This term was a power m plus 1 minus k into b power k plus b power m plus 1. What is this expression? This is the expression, just k equals to 0 to m plus 1, m plus 1 choose k, a power m plus 1 minus k into b power k. What is this? This is exactly the right hand side of p m plus 1. Do you get it what I have shown? We are trying to show that p m plus 1 is true. This is what we are trying to show. What is p m plus 1? p m plus 1 means a plus b, using this definition of pm, I mean a plus b whole power m plus 1, that has exactly the expression summation k equals to 0 to m plus 1, m plus 1 choose k, a power m plus 1 minus k into b power k. Okay, this is the hypothesis Pn we had. This is the statement. Put n equals to m plus 1, then this will give you the exact expression we are trying to show. Okay, so here if you put n equals to m plus 1, then left hand side will give you a plus b whole power m plus 1, and right hand side will give you summation k equals to 0 up to m plus 1, m plus 1 choose k into a power m plus 1 minus k into b power k. This is the right hand side. So see, after this calculation we have taken LHS equals to this, and after calculating in this way, what we are getting? We are getting this expression, which is exactly the right hand side of the expression p m plus 1. So therefore p m plus 1 is true. 1 minute.
Sorry, do you have a key?
Yeah, I have key.
Okay.
Sorry. So we have shown that Pm plus 1 is true. Assuming that Pn is true for 1 up to m, we have shown that Pm plus 1 is true. So the second sorry. Okay, let's start it again. So what we have shown that Pm plus 1 is true, assuming that Pn is true for 1 up to m. We have shown that Pm plus 1 is true. Therefore, the second condition of the principle of mathematical induction holds. So what we can conclude? Then by principle of mathematical induction, we have Pn is true for all n belongs to n. Therefore, the statement we wanted to prove that holds for any natural number n. This is how we use the principle of mathematical induction to prove some given statement. So this will give you the procedure to prove, but to guess any statement, I mean something will hold, it will not work to guess that kind of statement. Okay, we just use it to prove some given statement, and this is the way we use it to show something. So this is the principle of mathematical induction. Next is so you have seen the lecture of lecture containing the division algorithm and all. So I will recall that one. So another important foundation stone, you can say, of number theory is the division algorithm. Okay, so what does it say? Anyone has any doubt up to here? I mean, for statement what we have said till now, or anywhere, any doubt? Okay, so yeah, one thing I forgot. First, let me show you that. So in the above proof, what we have used that m choose k. What we have used? Okay, m choose k minus 1 plus m choose k. This is equals to m plus 1 choose k. That is what we have shown. So let's see the proof. LHS equals to m choose k minus 1 plus m choose k, that is exactly m factorial k minus 1 factorial into m minus k plus 1 factorial plus m factorial up to k factorial into m minus k factorial. So from here what you can see is, if you take common m factorial upon k factorial into m minus k plus 1 factorial, what you can get is what you can you will have in this bracket, that is what will be here from this side. K we will have k here plus what from this second term. From this second term we will get m minus k plus 1. This is from the first this one, and this is from the this one. Okay, so you can see this will give you m plus 1 factorial upon k factorial into m minus k plus 1 factorial. Okay, so it is showing call will end in 1 minute. So let's end it and rejoin with the same link. Is it okay?